Welcome to Supercool, the show about low-carbon innovation now scaling. Each week, we talk with the founders, CEOs, and executives whose companies are winning customers, growing revenue, and capturing market share by turning carbon-cutting ideas into competitive advantage. This is the rise of the low-carbon economy, a multi-trillion-dollar transformation already underway. I'm your host, Josh Dorfman. In 2005, I moved to Greenpoint in Brooklyn. It was a traditional Polish neighborhood on the northern edge of what was fast becoming hipster Williamsburg. My apartment eventually became the furniture showroom for my first sustainable venture, a company called Vavavi. It was right above a restaurant specializing in goulash, and the aroma was ever present for the intrepid interior designers who came all the way from Manhattan to see our contemporary sustainable furnishings. Greenpoint was full of low-slung buildings running for over a mile from my apartment to the East River, looking out towards Manhattan. Back then, the closest thing we had to geothermal was steaming manholes. But last month, that all changed. The Rivery, an 834 apartment complex, opened its doors, and it's heated and cooled by the ground beneath it. In fact, even the rooftop pool runs on geothermal. When I read that it was made possible by hundreds of boreholes drilled hundreds of feet underground, I had a couple of questions. Who actually does that work? And how do you do it in a dense city where there's already a whole other city beneath your feet? Water, gas, electric, telecom, subways, and other foundations. How do you drill that many holes that deep under a place like Brooklyn to deliver a real alternative to fossil fuels? That question led me to Geosource Energy and to Stan Reitzma, a geological engineer who's been building this industry for over 2 decades and who's helped turn Geoexchange from a simple idea into a decarbonization pathway for cities. Geoexchange is straightforward to explain and very difficult to execute. You drill vertical boreholes hundreds of feet below ground, and then use heat pumps to move heat in and out of the ground depending on the season to supply heating and cooling. It's fully electric, no fossil fuel combustion on site. But in a dense city, you're not drilling in an open field, you're drilling on a construction site, often right where a building is about to go up, on a schedule where a delay can cost more than the geosystem itself. Stan told me about an early urban drilling job so brutal, basically drilling from inside an active excavation, that he swore he'd never do it again. Then he spent the next 15 years solving the problem, drilling from grade so they can get in early and get out of the way, and then capping and protecting their loops so the system can survive years of construction above it and be ready the day the building comes online. Geosource also developed specialized angle drilling, letting them build a large underground bore field from one small drill pad, 850 feet down, spreading 350 feet out at a 25-degree angle. And that's how you convince developers and city officials that this can be done without major disruption. Geosource has completed more than 400 projects, and Stan calls it 500-year pipe, meaning the underground loops can last for centuries. He's seen a building come down and the borefield stay put, and then the next building ready to go up. Building owners choose Geoexchange for the operating savings. And for every dollar saved at the building level, the grid saves $8 or $9 because Geoexchange also cuts peak demand when electricity is most expensive and most scarce. That is a true decarbonization driver, and it's why cities from Toronto to Boston to New York City are leaning in with more to follow. Hey, quick break before we jump in. Do you have a high-performance building strategy? Do you know why you need one? Building codes are evolving fast. Decarbonization goals, electrification, air quality, resilience. The standards are getting more rigorous, and they no longer only apply to construction. They follow your building into operations, which means if you're responsible for how a building runs, this is on your plate now too. Johnson Controls has been on Supercool. We're big fans, and this month, they're launching a new webinar series on building performance standards, and we're partnering with them to bring it to you. The first session is on March 19th from noon to 1 Central Time. It's hosted by Rob Tanner, who has spent 2 decades reimagining the performance of buildings to serve people, places, and the planet. He'll be joined by Josh Brackett from Banner Health, where he leads compliance across both operations and design and construction for all of its healthcare facilities. It's free to join, and it might be the most useful hour you spend understanding how evolving building codes are shaping high-performance buildings. Find the link to sign up for this virtual fireside chat in the show notes. And now, here's my conversation with Stan from Geosource Energy. Welcome to Supercool.
Yeah, thanks for having me.
So I was saying briefly before we hopped on air together that when we found the building, the Rivery in New York City, and understood the extent of what had gone on to install geothermal to run this huge building that's right on the East River, the Brooklyn side, Greenpoint, where I lived for 5 years. As we understood that, that led me to your company, to Geosource. And I was like, oh, this is so fascinating. Let me reach out. I want to understand this industry. I want to understand how it evolved, how we got here, where it's going. And what was so fascinating to me is that you've built this company, or you started it over 2 decades ago, and started it with, as I understand it, your brothers working together. So I'd love to hear just the background of how you came to start this company and kind of the founding story. And then we'll talk about how the company's evolved and the industry's evolved from there.
Absolutely, yeah. So we started in 2004. I was a professor of civil and environmental engineering in the University of Windsor, so I could see Detroit skyline from my office window. And the Ambassador Bridge, which is on the news these days, that was my home. And I was there for 7 years, a Canada Research Chair. But energy has always been my interest. I'm a geological engineer, so ground kind of made sense. Of course, it's a bit of a journey on the decision to come out of academia into starting a business like Geosource. But one main driver is, fossil fuels are finite. I think we all know that. I heard about geothermal when I was probably in grade 2, and it resonated. A young kid during oil embargo, and it surprisingly has always stuck with me. And working with my 2 brothers, very different backgrounds. I'm an engineer with lots of academic and research oriented, and obviously still very practical. I grew up on a farm, so I knew what a machine was. One of the brothers was a helicopter pilot. Stopped doing that because he wanted a family and didn't want to live up in the bush. And the other brother was in landscaping and construction, retaining walls and pavers and all that kind of stuff. And so we got together. And that's that, as they say. And then, of course, we've grown a lot.
The growth trajectory, as I've come to research your company and getting ready to talk with you, seems so fascinating to me. One of the things that seems so interesting is that you started this company in 2004, I believe. The landscape of what you must have been seeing, or the opportunity that you were seeing, is far different. I mean, maybe you were seeing that geothermal, and in this case, the Geoexchange technology of what you're doing kind of within the urban environment as you're putting in geothermal. Maybe you saw this coming, but the business opportunity couldn't have looked like this 20 years ago, right? This was still pretty nascent if you're talking about jumping in and starting a company. So I'm just kind of curious, if you go back, like, what were you seeing? What were you and your brothers keying into that said, oh yeah, this is a really good idea? Was Canada further ahead? Was Toronto further ahead? Were you seeing that there was already kind of a market forming? Or how did you think about it back then?
Well, there were a couple items. One was the shale revolution for oil and gas was not yet a thing. And of course, I'm a geological engineer, so I'm, worked for Mobile Oil and Petrocan and some of these places. And I knew about peak oil and all those conversations. So that was part of the calculus, right? Conventional gas had peaked in 2002. And it was pretty clear and, going to end up with a supply shortage. Let's put it that way, right? Now, did that materialize? Not exactly. Shale came along and changed the timeline of that by a decade or 2, but we're not too far away from that again, I believe. So that was part of it. And then, yes, there was some initiatives in 2000, some incentives that were happening in the provincial and federal level in Canada on heat pumps for retrofitting of houses. And that's where we started. The business started with houses, and we did that for a few years. And then as larger projects started coming on the scene, we gravitated to those and realized that for us made a lot more sense than the housing market. My view now on houses is when we start doing whole subdivisions and whole communities and convert them over with the TENS type thermal energy networks or whatever way that looks, then it'll be time to get back in. So you asked the question, where did it start? It started very small 20 years ago. And now we're doing, about 30% of all new high-rise, mid-rise stuff happening in Toronto area, for example, is geothermal. It's hard to imagine than 20 years ago, right? I didn't even know what a great big building like that involved. So for me, it's partly like the technology makes a lot of sense. It still does. Nothing's really changed there other than we can deliver better. And the market forces slowly pick up and understand that this is a good technology. And then, of course, it progressed.
So the urban environment for tall buildings, big buildings, I found you through the work that your company had done on the Rivery, this big building that just opened in the Greenpoint neighborhood in Brooklyn, right on the East River. Huge, beautiful building. As I was reading about the hundreds of boreholes that had gone in under that building and wanting to understand who does that work, that's how I came to your company. But geothermal in that context, where geothermal is coming in and it's going to provide heating and cooling to the building, you all really talking about that actually as the Geoexchange, not geothermal energy, drawing some distinction, let's say, between what we're hearing about more in terms of geothermal as a utility scale type provider of energy, maybe a company like Fervo or a whole bunch of companies who are working in that space. So can you tell our audience a little bit about the technology itself, what we mean by Geoexchange and what you're doing on a building like the Rivery and other projects that you work on?
Unfortunately, some confusion in the industry on geothermal, and there's been some hesitation, move away. Geoexchange is partly why the word probably Geoexchange was invented, to get rid of some of that confusion. So there's really two types of geothermal. One is high temp, which will go into depths of 3, 4, 5, 6 kilometers down or 4 miles down or whatever to get the temperatures where the rock is hot enough to start boiling water, essentially. That, of course, is not what we're doing for buildings. We're basically providing a heat exchanger with the ground, and which is why it's called Geoexchange, transferring heat back and forth from the ground every year. So in the wintertime, we take heat out of the ground, we refrigerate the ground essentially and put the heat in the building using a heat pump to move that heat. And in the summer that reverses and the heat is then pulled from the building, put back in the ground and stored for the next winter. So that's just a cycle that goes every year. In order to do that, we basically put a bunch of pipes in the ground. Most of the time we're using high density polyethylene pipe. The same pipe is used for water mains and close to what's used for gas mains and so on. Pipe that'll last for hundreds of years and underground. And that pipe has now got fluid going through. And there's different versions of this, but that's just the one we do most of the time, is basically what we call closed loop, where there's fluid going through the pipe that is being heated or cooled with a heat pump and then interacting with the ground to pull heat in or dump heat back to ground. That's Geoexchange, or low temp geothermal, ground source heat pump. And I think it's an important question to ask. Why? One is we're getting a fully electrified building. We no longer need fossil fuels to heat the building. It's efficient even when it's really hot or really cold. Its demand on the grid remains very consistent. You look at Texas with the recent cold snap, or some of the, we've seen other places like that where it gets really hot out, the grid starts overloading and you start getting blackouts and so on because of that. Geo reduces that risk because it remains efficient even when it's very hot or very cold. And so we're starting to see jurisdictions, Quebec, for example, which has a massive incentive for geothermal right now. And it's almost to the point where we'll pay half or 3/4 of the geo install for houses and even into bigger buildings to reduce that peak. Because what they're trying to do is sell more power at those peak times into New York, for example. New York has a serious power demand issue. Having less demand at those peak times really helps, and it's significant.
Yeah, that's so interesting. What you mentioned about Quebec is interesting too. We just wrote about the transmission line that just came on that's sending hydro from Quebec through Maine down to the Massachusetts grid. I think it's 10 to 20% of the energy demand of Massachusetts, which is what it can get up to. It's really interesting when you just think about energy security, or a place saying like, how do we think about this economically? Well, if we can do geothermal here, maybe we can take these other resources and send them somewhere else and get paid to do that. But it's really changing so much of the thinking. And I guess my question, Stan, when you say these things out loud, they sound incredibly obvious. Yes, you're describing the ground. It's at a constant temperature. I mean, I know you've evolved your technology, and I want to talk about what differentiates the way you guys drill and how you've grown your business and been able to grow so successfully. But as you're describing it, and as I understand it, it just seems to me the argument for geothermal or Geoexchange in a city, it's just one of the things when you have this conversation, you think, why hasn't it happened already? And you've been in this for 2 decades. You've seen like how it is starting to happen, but I mean, I don't know. How do you respond to that?
Well, so one of the questions I often get, does it work? Right? That's a fear because they have never done it before. And then sometimes they ask me how it works. And I go, do you know how your refrigerator works? And they go, well, no.
No.
And I'm like, okay, does it work? Yeah. Do I have one? Yes, I have one. So the point is, do you need to understand it to buy it? So, a little bit of a trust thing that needs to build. And I think that that's a reality. And then, of course, a lot of it has to do still with things have to catch up. We can deliver stuff, but you got to deliver it at scale. Let's say all of a sudden everybody in New York wanted geo. Well, we couldn't do it. So there has to be this buildup. As the market grows, the capacity to deliver on it needs to grow. The way we did it in a football field for a school, for example, from 25 years ago, doesn't work in the middle of downtown New York because there's no room. Buildings are already all there, and we got to go and get under those buildings somehow and get the stuff in there. Those are the sort of solutions that need to come along as the demand grows. We need to start providing solutions that fit. You got to experiment sometimes. It is coming to the point where, City of Toronto show people now, I go, that building is geo, and that building is geo, and that one's going geo, and that one's going geo. And then they have no idea. They're like, what? I go, yeah, these are all, did you look at this building? I go, yeah, we looked at that one. In fact, we're looking at doing a retrofit for this building. We're going to get inside the parking structure and we're going to go do it. And they're like, there's no way. I'm like, well, and so financially is a big question mark too. And I think our view is we're getting, even without tax credits, you got, I'm not sure what it's called now, IRA tax credits or Big Beautiful Bill or whatever, wherever that rolls into, but that concept is still there for geo in the US. Canada has its counterpart to that called ITC, Investment Tax Credit. Those are layering in and adding more drive to make it happen, but it still doesn't change the underlying economics really that much. It needs to be lower cost to operate than conventional, otherwise the returns don't exist. And we're finding that the returns do exist, and we're getting 8-10% rate of returns on the investments on geo, which is enough for building space where the asset lasts for at least 30 years. That's usually how these are being looked at, but we know that they're going to last way longer than 30 years.
So I want to ask you about the technology. Before I do, just to stay on the economics for a second and the financing. I've talked with this company, totally different industry, called Forum Mobility. Their business is to get truck drivers who are working at ports, so on drayage, taking the container ships off the ports, get them into electric semi-trucks. Right now, those electric semi-trucks can cost $400,000, so it's big expense. And the drivers are often smaller family-owned businesses. It's a tough calculation. So they've said, okay, how do we flip this? How do we do this as a monthly subscription that also includes charging and still underpriced diesel? And the guy who started the company came out of solar. And so he understood, and he had the acumen to be able to go to whichever financial partners and say, look, these trucks, these electric semis from Volvo or whomever, they're going to last a really long time. So let's change the type of financing that you're offering me. I need more like solar type financing because we know solar is proven. This is proven. So I need more favorable financing. I'm wondering if like Geoexchange for some of these buildings is sort of on a similar curve where the financing gets better as the confidence level goes up because systems have just been in place longer.
Yeah, it's a good example. They don't fit how things are being financed or being thought about in terms of the truck lasts longer than a conventional maybe, or it costs more up front. And now, you got to figure out, does it have OPEX payback, right? That's the same with geo. It's a cost more to put in front. It lasts for a long time. How do we do that? There are quite a few providers now that do energy as a service in geospace, but I do see it energy as a service happening for things like universities and colleges. Maybe some government institutions might do that, where you get your big Cordy Energy or N-Waves and all those types are maybe involved, right? That do thermal energy networks already, and they just keep building off their district energy systems. And then there's lots of private equity out there trying to find places to go put money for those types of returns. It's definitely happening. And I think that matching of timeframes of 30-year money with reasonable rates of return and expectations that match is helping. And eventually, I mean, the way I see it is eventually you're going to see your big utilities, maybe, just like they did with all the gas infrastructure or water networks or all those type of things. This is not that far off of that kind of implementation, right? It's the same. It fits that utility type investment.
Yeah, that makes sense. That definitely makes sense. I appreciate you walking me through that. Switch gears for a second, because I do want to understand the technology. I do want to understand what it means to be in a city, whether Toronto or, again, the Rivery in Brooklyn, and to be in that kind of dense city where there already is a lot of stuff underground. There already are pipes and infrastructure and stuff below that you probably have to figure out how you're going to not mess up when you're building, right? And this was something like 340 or some odd boreholes underground. So can you take us through what is that process like, and how is your company differentiated? Because it sounds like you are, and what you're able to do.
Yeah, so I think we're getting into how did we start putting geo into dense urban environments as opposed to maybe what would be more traditional geo going into a country home or maybe a school with a football field. And we were faced with this in about 2007, and we're asked a question, and we did a job where they wanted it under the building, right? And it wasn't, I wouldn't say our idea. We were just faced with it, and that was really the only option they had. It's very common with a building going up with its basically the parking structure that's being built is right up to the lot line, and then sidewalks all the way around, and then the street. There is no place to put geo other than under the building. We ended up drilling that job from inside the excavation of the future building, and it was the worst drill job we ever had in our life. And I swore that I would never do that again. And so this is where we came up with the next job we had for it was Toronto Community Housing Project right near Maple Leaf Gardens, which is where the Maple Leafs used to play. Interesting area. It's a bit of a I saw some things that I can't unsee, but drilling there we did from surface. And we basically started doing this under what we call at grade or underbilling countersinking, right? And that was the first one we did that. And that was 2008, proof of concept had a few little issues and wasn't the easiest to do. So we kept improving that. But basically what we do now, and we have patents on this and so on, but the idea is drill from top of, let's say you're going to put a new high rise in, there's an old plaza or maybe a couple houses that are rentals for a few years and now they're time to go down. They'll tear those houses out or the plaza. We go and drill from after those are out. We drill our 100 boreholes to 850 feet below the future building, right? So we're not drilling from excavation. We're not in the critical path quite often because we can get the drilling done prior to all the real action starting to happen in the construction. So from a cost standpoint, really reduces cost and gets rid of some of the risks and so on around the construction. Let's say there's 2 P levels, so it might be 25 feet down eventually where they dig to. We'll plug the pipe at 25 feet below. So it's basically a loop that goes in and we put plugs in there. We cut the pipe above those plugs, remove the pipe out above those plugs. So now when they go to excavate, it's as if we were never there. When they get to their subgrade elevation of 2, 3, 4 P levels, whatever it is, we then re-expose those pipes because they're sitting where we left them. And we pull them back up through raft slab or, around the foundations and do all that piping from those boreholes now to the mechanical room. So that's the process essentially. Almost 90% of the work that we do these days is under buildings like that. And it's from grade. And some of the kind of nuance of it is how do you do the plugging? We've learned that they tell you the elevation is, 20 feet below, but every once in a while they dig to 30 feet below instead because they got to put a crane in there or the elevator shaft's got to go in and they forgot and they cut back and they do all these things. And you got plastic pipe in there. That's like, I have to chuckle sometimes. One guy told me, oh yeah, we worked around, we were really careful. And I asked him what size machine was. It was a 40-ton excavator. I go, yeah, okay, yeah, you were careful. Yeah, right. So what we learned though is that we had to plug at the elevation they say, and then we plug another below that, and then we do again. And sometimes when we really get worried about, we may have 10 or 15 feet of plug zone in there. If they were to shear through the pipe, there's still another plug below it. That's really the trick to getting in urban environments. So the other piece that we're really starting to push on, and we've been working on it for a long time, but we're seeing an uptake, is angled borehole drilling. Basically what it is we drill from a very small footprint at surface, right? Maybe a laneway, a little green space or cul-de-sac, something that's pretty small. From there, we reach out 850-foot borehole at a 25-degree off vertical line. We'll reach out over 350 feet. So we can get an awful lot of capacity from a very small area by starting at surface and then sending it out underneath buildings and green space or right-of-ways, right? Conversations that we're having with the City of Toronto. If we need to get more capacity, we can't get it out from underneath the building. Drill out from the building out under Parkland, for example, or the roadway and come out at 150, 200 feet down and then enter into the adjacent property. So those are kind of stuff that we're bringing to add capacity, put it into smaller spaces. Angled holes also help a lot with interference on constructions. We go drilling over here and we keep apart from each other, but we're actually just reaching out underneath their work. Then the project can move along without interference on the drilling side from a scheduling standpoint.
Well, that's really cool.
$500 million building. You delay them a week, it costs more than the geo ever cost in the first place. Right? So the schedule is everything in construction. And we have to bring things to the table that do not impact schedule, or at least minimize the impacts.
And so as you're growing your business, Stan, what's that conversation like with, well, I guess maybe my first question is, what is the sales process like? Who do you engage with? Is it the developer? Is there like a whole slew of consultants involved? I'm curious about just the sales process. And then I'm also curious about the value proposition. Someone's going to want to know, okay, yeah, we can do this cool angle drilling, but I imagine somebody else is just going to want to know, like, great, you're going to be on schedule and you're not going to get in the way. Okay, check the box. You're speaking the language that I need to hear. Because also when I was reading about, again, coming back to the Rivery in Brooklyn and just not understanding, you guys drilled the boreholes. There was some other company that actually installed the geothermal. I didn't realize it's so kind of multifaceted on these huge projects.
There's big teams there, right? Like on a construction like that, there's many, many trades. And of course you got a GC and an owner. So there's a whole bunch of interests and different groups that are managing those interests. We're 1% or maybe 2%, which is good. It's not that big of an expense, I guess is the way to put it. But process is going to be driven a lot by the type of building. And I think there's some questions a little bit about that is, okay, so multi-residential buildings is private companies, lots of family-owned companies or generational companies that are doing this, right? Companies have been in the space of building rentals for years. And then you got hospitals and university projects, those type of projects are much more usually bid spec projects. In fact, they've gone through their whole process and we're just kind of there at the last minute. Great to be in that. We like that as well. We're very close to starting a project in Staten Island for New York School Construction Authority. We're bid to a GC. GC had bid on the whole project and we're a piece of that. So we're coming along for the ride and never were part of the development of that project, which probably was in the works for, 5, 7, I don't know how many years, right? Long time. So those ones we don't get that involved with other than always being there, right? And I think the consistency and the longevity that we've had of 20 years, the trust level is starting to grow just for the technology. So the school boards can start looking at this going, yeah, we know what it is and we can get it, right? That's what we want. So those being there is still part of the process. Developers, you're right there. So the intention is that we're in there right away as soon as we can. We start talking to them about what it is and why it works and what is the returns, and we can hit your schedule and this is how we would do it. And meeting quite often with a developer, they'll have their construction team in there, they'll have their finance team in there, they'll have compliance maybe or permitting, right? So they have a bunch of different groups in there that all have their own questions and their own concerns. And we work to address as many of them as we can in getting there. And then, of course, a big part of it is our end. We spend a lot of time with the engineering groups and architects and try to show them, this is the way you're thinking about it. Look, we'll bring it at grade, for example, or we'll bring angled holes. And we've got a few of those now that they either shelf the project and then you bring another solution to them. They're like, okay, that actually might work. We have a nice college that was doing geo and they looked at it. They were concerned about parking. Like, we're going to lose all this parking. We can't do it. Who knows who's upset about that, right? Somebody. And so you remove that problem and suddenly they go, oh, we can do angled holes and we just got a little strip along the side, or we can do it in the green space along whatever. All of a sudden we remove the barrier and suddenly it's like, okay, it's a go again. But I think the construction aspect is, to us, has always been the interesting piece. For me, just personally, I enjoy trying to figure out how to piece it together. It often is what makes it work. And I think as we do that more and more, there's more and more uptake. I think we're just trying to knock down all the barriers that are in the way. Department of Energy put out a study in 2023, I believe. There's one in Canada very similar, which is where Quebec picked that up and went, okay, let's study that further. And then they went, okay, that's why we're going to incent geo to a level of $50,000 a house or something. It's so much grid impact that we just are going to basically give geo away. The DOE study was very similar to that, showing that for every dollar that I, as a geo installer or a geo owner, let's say, somebody, I bought it and put it in my house, for every dollar I save, the grid saves 8 or 9, which I don't see. The neighbor sees it and the next neighbor, and it gets spread out. But those are the things that are going to start driving the math on this, I think. The grid impacts and the resiliency in the grid and the ability to do other things, data centers, are all going to be pulling for that power. You can start nailing that problem by putting geo in, at least helping it. There's big money in that. What would have been a 10-year payback, if you could capitalize what was happening on the grid, it would be a 1-year payback. Everybody would do that in a heartbeat. And so I have a friend of mine who jokes, he says, somewhere in there's a business model.
Are you getting calls from data centers? Like, as they think about heating, or is it in particularly cooling? Is that coming up?
It is. Our view is starting to do cooling with lower power solutions when there's no grid, when no power available, which may include geo, and then dump that heat. We can get rid of heat in the wintertime real easy, right? So we can dump heat in the summertime into the ground and then restore that ground with fluid coolers in the wintertime. A big part of it will be water consumption as well. So we're already seeing DOE has some effort that they're looking at. I think NREL is looking at something related to data centers and trying to make data centers use less water. In some places that's not a problem, but there's other places that's going to be huge. Anyway, there's solutions. Yeah. The scale is just so immense. But I'd love to.
We've poked at it on this show, just that when you're getting to gigawatt scale and you can't, like we've talked with Schneider Electric, they're like, yeah, we prefab everything. Like, it's just too big to manufacture things on site, manufacture racks. There aren't enough electricians to install stuff. It's just so beyond. You've got a lot of market penetration, and your company's done a lot of buildings in Toronto. You are active in New York City. I know you're in other geographies too, but to what degree does policy at the city level also drive uptake and adoption of geothermal, in this case, the Geoexchange technology we're talking about?
It's huge. I mean, the reason City of Toronto probably has so much geo is because it has a green standard. Green standard is really starting to kick in. It's basically a higher building standard than, say, provincial or the minimum bar, right? They've upped the bar for efficiency and emissions. Boston's got the same thing coming, and then New York City has local law 97 and some other, I don't know all the things that are going to happen there, but those drivers are going to make the decision easier because you already can do it. Okay, we can already say it has return, but then they're looking at going, okay, but you're telling me I can meet compliance because I do this and I get returns and it doesn't, and the answer is yes, 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 right? Then suddenly the no goes away a lot quicker. I see quite a bit of increase in New York activity even from 2023. We did a school in Boston last summer called JFK Elementary School, and that will be finished this summer because I had to wait for the summertime when the kids are out. So it's a retrofit. It's small, but it's a beginning, and the city of Boston is very aware of the project, and they got more coming in terms of social housing. I think, yes, I think the answer is local has a huge impact on uptake. And we start to see it peel out into the surrounding areas as that happens because the same developers or the same people are involved, see it, and then they go forward.
So play this out for me, Stan, because I'm just trying to think this through and thinking about the Quebec example we talked about and some of their reasoning for wanting to incentivize folks to adopt geothermal. Let's say Boston 5-10 years from now, but geothermal is becoming really far more significant, or New York City, or, in Toronto, it keeps going. Now, I could see at some point you reach some scale where for New York City, it is a huge advantage to have all of this energy being produced locally. Some reasons it seem pretty obvious, like resilience, maybe some power dynamics vis-a-vis the grid or utilities, and they kind of control more of their destiny. Does that create also its own momentum, do you think, where then other cities are like, oh, it's not just about complying with climate legislation or ideas about cutting carbon. There are all of these other reasons that are more strategic for a city to adopt, what the early adopters have done, a Toronto, a New York City, maybe a Boston. Is there a logic there that then starts to speed this up, where other parts of Canada or the US are like, oh, we're falling behind in some way, or we're not fully controlling our destiny if we don't go do what these guys do?
If the technology is a money saver, for example, you will fall behind if you're not doing it. We're starting to see that now. The questions from consumers are, is it all electric? Because, hey, I mean, one of the anecdotal, but one of the things that you don't realize, but when you have an all electric building, especially Geo, and I don't know if air source would be the same or whatever, I don't have a reference point for that, but I've been hearing from the property managers that they're way easier to keep clean. And you're going, okay, so they're way easier to keep clean. Why are they easier to keep clean? They're electric. Was gas boilers dirty? I don't know. We're learning that gas stoves in our house aren't great. People are smart enough to understand that maybe they just weren't aware. We're not fleecing them. It isn't greenwashing. We're just trying to make a whole bunch of money. We're delivering a solution that's a little different, but it works and it pays and there's returns.
Two probably related questions. How does your company define impact? I mean, I'm sure we can quantify some carbon through our project saved or on any given project, right? You can quantify that. I'm curious how you think about impact for the company. And then for you, maybe it's related, but like 2 decades on, like what drives you? Are those two things related? What gets you up in the morning?
And there are days when I just have to get up and go do it because I don't want to. But let's say when you're getting the wins, okay, which isn't every day. Two things. One is believing that technology is maybe a strong word, but I feel it's very good. There are no downsides to it. And it's a big part of me is to call it sustainability. I know it's such a kind of overused term, but this idea that you aren't using anything. I mean, yes, okay, electricity, but we can get that from a lot of places. And we have other alternatives to generate electricity over time. It'll transition into something from fossil fuels or whatever. But this will be there in 100 years from now or 200. And I joke about it quite often because I call our pipe now 500-year pipe. And it's because the pipe is 10 times better than what they used to call 50-year pipe, which I know lasts 50 years. Okay, I think it lasts 50 years because we have stuff that's been in for 22 years and it's still working. And if we go dig it up, it looks exactly like when we put it in. It probably isn't quite, but it's close. Pipe that we put in now is 10 times better, so I call it 500-year pipe. right? So I joke and I go, look, this stuff will still be here and someone will wonder who put this in 500 years from now, but they're going to go, it still works. And there is infrastructure out there that lasts like that. Romans and, Mesopotamian. I mean, there's stuff that's around for a long time and it's surprisingly still being used. I think that's what we're talking about here. And for me, that really resonates. I think building stuff that will last, especially for building stuff we live in, is going to be really important. We're putting something in that will last that building and maybe the next one. Right? Tear it down, put it on. I've seen that. I've seen it where they tore down the school and just hooked right back up to the geo that was already put in and just firing the next building on, heating, cooling the next building with the same system. So I find that interesting. Why do I do it? I don't know. It pains me to see that things are changing. And I can see it. I can see it in vegetation. I see it in the types of, I can see that change. We all can probably if you're paying attention to it. I want to make a difference. I don't want to just tell other people that they should do it, right? I want to be part of that. So that's what gets me up. Keep pushing.
Appreciate you sharing that and sharing also really what drives you. Yeah, this has been a really interesting conversation from where we started and kind of coming back to that at the end as well. Thank you for coming on and thank you for sharing your story and what you all are doing. I'm so excited about it.
Thank you, Josh.
And thank you for listening. If you're enjoying Supercool and appreciate our conversations that merge climate, innovation, and commerce, please take a moment to subscribe and leave us a review. It's the best way you can help other future-forward decision makers find this conversation too. See you next time.